Welcome to this comprehensive exploration of the law of tangents. Today, we're going to discover a fascinating trigonometric identity that provides a unique approach to solving triangles. The law of tangents is a trigonometric relationship that connects the sides and angles of any triangle. Just like the law of sines and law of cosines, it gives us another way to find unknown measurements in triangles. Here's the law of tangents formula. It states that the ratio of the tangent of half the difference of two angles to the tangent of half the sum of those same angles equals the ratio of the difference of the opposite sides to the sum of those sides. The law of tangents joins two other fundamental trigonometric laws in our problem-solving toolkit. The law of sines works best with angle-side-angle situations, while the law of cosines excels when we know three sides or two sides with their included angle. The law of tangents provides a unique alternative, especially useful when you have two sides and the included angle. It offers a different computational approach that can sometimes be more convenient than the other methods. Throughout this video, you'll master the law of tangents formula and understand exactly when to use it. We'll work through detailed examples, explore real-world applications, and share practical tips to make your calculations more efficient. By the end of this video, you'll have a powerful new tool in your trigonometry arsenal. The law of tangents will give you another way to approach triangle problems with confidence and precision. Now that we understand what the law of tangents is, let's dive deep into the formula itself and understand exactly what each component means. Here's the complete law of tangents formula. This equation connects the tangent functions of angle combinations to ratios of triangle sides. Before we break down the formula, let's establish our triangle notation. We have a triangle with sides A, B, and C, opposite to angles A, B, and C respectively. Let's start by examining the left side of our equation. This is a ratio of two tangent expressions involving our angles A and B. The numerator contains the tangent of half the difference between angles A and B. This represents how much the two angles differ from each other. The denominator contains the tangent of half the sum of angles A and B. This represents the average relationship between these two angles. Now let's examine the right side of our equation. This side deals with the triangle's side lengths A and B. The right side is much simpler. The numerator is just the difference between sides A and B, while the denominator is the sum of sides A and B. Now let's see how this formula connects the angles and sides of our triangle. The beautiful relationship shows that complex angle combinations equal simple side ratios. The left side of our equation uses angles A and B from our triangle, combining them in a specific way using tangent functions. The right side uses the corresponding opposite sides A and B, creating a simple ratio of their difference to their sum. The key insight here is that this formula transforms complex trigonometric relationships between angles into simple arithmetic relationships between sides. This makes certain triangle problems much easier to solve. Remember this complete relationship. When you know two sides and need to find angles, or when you know angles and need to find sides, this formula provides a powerful tool for solving triangles. Now that we understand what the law of tangents is, the natural question becomes, when should we actually use it? Understanding when to apply this law is crucial for solving triangle problems efficiently. The law of tangents is particularly useful in two main scenarios. First, when you have two sides and the included angle between them. This is called the SAS case, side, angle, side. The second scenario is when you have two angles in one side. This could be either AAS, angle, angle, side, or ASA, angle, side, angle, depending on the position of the known side. Let me show you these scenarios visually with actual triangles to make this clearer. Here's the SAS case. We know sides A and B and the angle C between them. The law of tangents helps us find the unknown angles A and B efficiently. And here's the AAS case. We know angles A and C plus side C. The law of tangents can help us find the remaining angle B and the unknown sides A and B. Now, you might be wondering, why use the law of tangents when we have the law of sines and law of cosines? That's an excellent question. Here's a comparison of when to use each trigonometric law. The law of sines is most commonly used for ASA and AS triangles, and it's often the first choice for many problems. The law of cosines is excellent for SSS triangles, where you know all three sides, and SAS triangles, where you need to find the third side first. The law of tangents offers an alternative approach for SAS and AAS triangles. While it's not always the most common choice, it can sometimes simplify calculations, especially when working with certain angle relationships. So when might you specifically choose the law of tangents over the other methods? First, the law of tangents can sometimes be computationally more efficient. For certain problems, it may require fewer calculation steps than other methods. Second, it provides an excellent way to verify your answers. If you solve a triangle using the law of cosines, you can check your work using the law of tangents. Finally, understanding all three trigonometric laws gives you a complete mathematical toolkit and deeper insight into how triangles work. The key takeaway is this. While the law of sines and law of cosines are more commonly used today due to computational accessibility, the law of tangents remains a valuable tool in specific scenarios. In our upcoming examples, we'll see exactly how to apply it in practice. Now we'll work through our first example using the law of tangents to find unknown angles in a triangle. This will demonstrate the step-by-step process clearly. Here's our triangle. We know that side A equals 10, side B equals 7, and angle C equals 50 degrees. We need to find angles A and B. Now let's solve this step by step. First, we'll use the fact that the sum of angles in any triangle equals 180 degrees. Step 1. We know that the sum of all angles in a triangle equals 180 degrees. Substituting our known value of angle C equals 50 degrees. Solving for A plus B by subtracting 50 degrees from both sides. Therefore, A plus B equals 130 degrees. Next, we'll find the value of A plus B divided by 2, which we'll need for the law of tangents formula. Step 2. We need A plus B divided by 2 for our law of tangents calculation. Dividing 130 degrees by 2 gives us 65 degrees. Now we'll apply the law of tangents formula to find A minus B divided by 2. Step 3. Now we apply the law of tangents formula. Substituting our known values, A plus B over 2 equals 65 degrees, A equals 10, and B equals 7. Simplifying the right side, 10 minus 7 equals 3, and 10 plus 7 equals 17, giving us 3 over 17. Now we'll solve for A minus B divided by 2. Step 4. We multiply both sides by tangent of 65 degrees to isolate the tangent of A minus B over 2. The tangent of 65 degrees equals approximately 2.144. Multiplying 3 over 17 by 2.144 gives us approximately 0.378. Taking the inverse tangent of 0.378 gives us A minus B over 2 equals approximately 20.7 degrees. Finally, we'll use our two equations to find the individual values of angles A and B. Step 5. Now we have a system of two equations that we can solve for A and B. To find angle A, we add the two equations. A equals 65 degrees plus 20.7 degrees, which equals 85.7 degrees. To find angle B, we subtract the second equation from the first. B equals 65 degrees minus 20.7 degrees, which equals 44.3 degrees. Let's verify our answer. A plus B plus C should equal 180 degrees. 85.7 plus 44.3 plus 50 equals 180 degrees. Perfect. Now we'll work through our second example, which demonstrates how to use the law of tangents to find an unknown side length when we know two angles and one side. Here's our problem setup. We have a triangle where angle A equals 70 degrees, angle B equals 40 degrees, and side A equals 15 units. We need to find the length of side B. Let me draw our triangle to visualize the problem. We have angle A at 70 degrees, angle B at 40 degrees, side A equals 15, and we're looking for side B. Let's recall the law of tangents formula. The tangent of A minus B over 2 divided by the tangent of A plus B over 2 equals A minus B over A plus B. Step 1, we need to calculate the angle expressions. First, let's find A minus B over 2. A minus B over 2 equals 70 degrees minus 40 degrees, all divided by 2. This gives us 30 degrees divided by 2, which equals 15 degrees. Next, A plus B over 2 equals 70 degrees plus 40 degrees, all divided by 2. This gives us 110 degrees divided by 2, which equals 55 degrees. Now that we have our angle values, let's substitute them into the law of tangents formula. Step 2. We substitute our calculated values. Tangent of 15 degrees over tangent of 55 degrees equals 15 minus b over 15 plus b. Step 3. Let's calculate the tangent values. Tangent of 15 degrees is approximately 0.2679, and tangent of 55 degrees is approximately 1.4281. Their ratio is approximately 0.1875. Now we can set up our equation to solve for b. Step 4. Now we solve for b. We have 0.1875 equals 15 minus b over 15 plus b. Cross-multiplying, we get to 0.1875 times the quantity 15 plus b equals 15 minus b. Expanding the left side, 0.1875 times 15 is 2.125, plus 0.1875b equals 15 minus b. Moving all b terms to the left and constants to the right, 0.1875b plus b equals 15 minus 2.8125. Simplifying, 1.1875b equals 12.875. Therefore, b equals 12.1875 divided by 1.1875, which is approximately 10.26 units. Let's update our triangle diagram with the calculated value. Side B is approximately 10.26 units. This example demonstrates how the law of tangents can be rearranged and manipulated algebraically to solve for unknown sides when we know two angles and one side of a triangle. In our next section, we'll explore real-world applications of the law of tangents in surveying and engineering. The law of tangents isn't just an abstract mathematical concept. It has important practical applications in surveying, engineering, and even modern computer graphics. Understanding these real-world uses helps us appreciate why this mathematical tool remains valuable today. In surveying, professionals need to determine property boundaries and measure land accurately. The law of tangents becomes particularly useful when dealing with triangular plots of land where two sides and the included angle are known. Consider this triangular property plot. A surveyor knows two sides measure 150 meters and 200 meters with an included angle of 65 degrees. To establish precise property boundaries, they need to find the remaining angles. The surveyor can apply the law of tangents to find the unknown angles B and C. This formula relates the difference and sum of angles to the difference and sum of the opposite sides. In engineering, the law of tangents plays a crucial role in structural analysis and mechanical design. One common application is in truss design, where engineers need to determine optimal angles for load distribution. Consider this triangular truss structure. Engineers need to analyze the angles between members to ensure optimal load distribution and structural integrity. The law of tangents helps determine these critical angles. By applying the law of tangents to analyze the angles in this truss, engineers can calculate the stress distribution in each member. This ensures the structure can safely carry the intended loads without failure. While modern technology like GPS, computer software, and advanced calculators have revolutionized surveying and engineering, understanding traditional trigonometric methods, like the law of tangents, remains essential. These traditional methods serve several important purposes. They provide verification for electronic measurements, offer backup solutions in areas with poor satellite coverage, help professionals understand fundamental principles, and meet legal documentation requirements in many jurisdictions. Professional surveyors and engineers who understand both modern technology and traditional trigonometric methods like the law of tangents are better equipped to handle complex projects and ensure accuracy in their work. In summary, the law of tangents continues to play a vital role in surveying for property boundaries and land measurement, in engineering for structural analysis and design, and in modern practice as a verification tool and backup method. Understanding these applications demonstrates the enduring value of fundamental trigonometric principles. Now that we've seen the law of tangents in action, let's discuss some essential tips and tricks that will help you use this formula effectively and avoid common mistakes. First, and most importantly, always double-check your calculations. The law of tangents involves multiple steps and half-angle calculations, making it easy to introduce errors. Verify each step. Ensure your calculator is in the correct mode, and confirm your angles are in the right units. Second, pay special attention to the half angles in the formula. Notice that we use a minus b divided by 2 and a plus b divided by 2. Don't forget that division by 2, it's the most common mistake students make when applying this law. Third, be very careful about sign errors. The order of subtraction matters greatly. If you use a minus b in the numerator, you must use a minus b in the half-angle difference. Mixing these orders will give you the wrong sign and an incorrect answer. Fourth, practice with different types of triangles. The law of tangents works for acute, obtuse, and right triangles, but each type may present unique challenges. Building experience with various triangle configurations will improve your confidence and problem-solving skills. Finally, remember that the law of tangents is just one tool in your trigonometry toolbox. Use it strategically when it's the most efficient approach, typically when you have two sides and need to find angles. Sometimes the law of sines or law of cosines might be simpler for your specific problem. Here's your quick reference checklist for using the law of tangents effectively. Keep these tips in mind, and you'll avoid the most common pitfalls while making the most of this powerful trigonometric tool. We've reached the end of our comprehensive exploration of the law of tangents. Throughout this video, we've covered the fundamental concepts, practical applications, and worked through detailed examples to help you master this important trigonometric tool. Let's quickly review what we've accomplished together. We started by understanding the law of tangents formula and how it's derived. We learned when this method is most useful compared to the law of sines and law of cosines. We worked through detailed examples, building your problem-solving skills step by step. We explored real-world applications in fields like surveying and engineering, showing how this mathematical tool applies to practical situations. The heart of everything we've learned is this elegant formula. The law of tangents provides an efficient way to solve triangles when you know two sides and need to find the angles, especially when other methods might be more complex. While the law of tangents may not be as widely used as the law of sines or law of cosines in everyday calculations, it holds significant value in the mathematical toolkit. It offers more efficient solutions for certain triangle configurations and provides alternative verification methods. In specialized fields like surveying and engineering, this law remains essential for precise calculations. Most importantly, learning the law of tangents deepens your understanding of how trigonometric relationships interconnect, making you a more complete mathematician. The best way to truly master the law of tangents is through consistent practice. I encourage you to work through additional problems, comparing this method with the law of sines and law of cosines to see when each approach is most effective. Consider exploring related topics that will expand your mathematical horizons. Advanced trigonometric identities, spherical trigonometry, and computational geometry all build upon the foundations we've established today. If this video helped you understand the law of tangents, please give it a thumbs up. Your likes help other students discover this content and show me that these detailed explanations are valuable to you. I'd love to hear from you in the comments. Share any questions you have about the law of tangents, or suggest other mathematical topics you'd like me to cover in future videos. Your input directly shapes the content I create. Don't forget to subscribe and ring the notification bell for more comprehensive math tutorials. I'm committed to creating detailed, step-by-step explanations that make complex mathematical concepts accessible to everyone. Thank you for joining me on this mathematical journey through the law of tangents. Mathematics is a continuous process of discovery, and every new concept you master opens doors to deeper understanding and more sophisticated problem-solving abilities. Keep practicing these concepts, stay curious about the mathematical world around you, and remember that every expert was once a beginner. I'll see you in the next video, where we'll continue exploring the fascinating world of mathematics together.